Hello students, I welcome all of you in today's session. In today we will discuss about irrational numbers, real numbers, and we will do exercise 1.2 question number 1 and 2. So I hope you have understood rational number. So before beginning, let's start revision of rational number. So rational numbers, a number that can be written in P upon Q form is called a rational number, where P and Q are integers and Q is not equal to 0. Also we know all terminating decimals are rational numbers. There are infinite rational numbers between two rational numbers. As you know that we can find many irrational numbers between two irrational numbers, and you also did questions based on it. And rational number can be represented on number line. We know rational numbers can be presented on the number line. Here in this picture you can see the number in the number line 3 upon 4 is a rational number, which is shown by the blue sign. Also 0, 1, 2 all are rational number. Let's see some examples of rational number. 2.5 that can be expressed as 25 upon 10, or by reducing the lowest term we can write it 5.5 upon 2. 6 upon 7 also a rational number that is written in the form of P upon Q already. Square root of 4 is also a rational number because 4 is a perfect square. So square root of 4 is equals to 2. Square root of 25, that is 5. 5 is a rational number. So number which are perfect square, their square root is rational number. 0.004 that can be written in the form of P upon Q, 4 upon 1000, or by reducing it into the lowest term we can write it 1 upon 250. And in the last example, minus 21, we can write it minus 21 upon 1 in P upon Q form. So minus 21 is also a rational number. So students, that was rational number. Now we come to the today's topic, that is irrational number. And according to definition, a number that cannot be written in P upon Q form is called an irrational number, where P and Q are integers and Q is not equals to 0. Let's see some examples of irrational number. Square root of 2, square root of 3, pi, square root of 15, 0.01001, 0001 dot dot dot. So these are some examples of irrational number. Why these are irrational numbers? Let's see. Students, when we find square root of 2, we get a non-terminating and non-repeating decimal. Here you can see the value of square root 2 is 1.41421356237 dot 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 dot. Similarly, root 3, root 15 and pi also. In the previous class we have done many questions based on pi. In area of circle we have used pi as 22 upon 7, but pi is an irrational number. For our convenience we use pi 22 upon 7, but pi is an irrational number. Now students, after irrational number we come to the next topic, that is real numbers. So let's see its definition. All the rational and irrational numbers make up the collection of real numbers. I repeat, all the rational and irrational numbers make up the collection of real numbers. So we can see this picture, real numbers are collection of rational numbers and irrational numbers. We can see rational numbers are given and irrational numbers are also given. So real numbers are the collection of rational numbers and irrational numbers together. And in this chart you can see the different types of numbers: natural numbers, all the counting numbers 1, 2, 3 and so on, whole numbers 0, 1, 2, 3. Whole numbers are numbers, natural numbers including 0, and integers -3, -2, -1, 0, 1, 2, 3, dot dot dot. The collection of whole numbers and their negatives are integers. And again, rational numbers, you can see numbers which can be written in the form of P upon Q. So here are different examples of rational numbers. Same irrational numbers we have just discussed, and at last real numbers, the collection of rational numbers plus irrational numbers. Now students, we come to the exercise 1.2 of NCERT. Question number 1, that is true false based question. The question number 1 says, state whether the following statements are true or false. Justify your answer. So we discuss it separately. In the question number 1, first part, that is, every irrational number is a real number. So as we know, real numbers are the collection of rational and irrational numbers. So it is true because real number are collection of rational and irrational numbers. So every irrational number is a real number. Second part, every point on the number line is of the form square root of m, where m is a natural number. So student, as we know, whenever we find square root of any natural number, we get either rational number, we get a positive value. But in the number line we see numbers are negative also and positive also. So this statement is false because negative numbers cannot be expressed as the square root of any other number. In the third, we see every real number is an irrational number. That is also false. As we know, real numbers are collection of rational and irrational both. So every real number is an irrational number is a false statement. Now we come to the question number 2 of exercise 1.2. Now the question is, are the square root of all positive integers irrational? If not, give an example of the square root of a number whose square root is rational. I think you have understood the question. They are asking, are the square root of all positive integers irrational? But we know when we find square root of any positive number, natural number, we get sometimes rational, sometimes irrationals. Let's see an examples. Okay, if we take 1 and we find its square root, we get 1 because 1 is a perfect square number, that is a rational number. But when we find square root of 2 and we get an irrational number. Same if we find square root of 3 we get a non-terminating and non-repeating decimal. So root 3 is an irrational. But in root 4, the value of root 4 is 2. So that comes a rational number. So we can say, no, the square root of all positive integers are not irrational. So students, we have discussed question number 1 and question number 2 of exercise 1.2. Question number 3 and 4 are activity based questions. We will do them later on. So I think you have understood irrational numbers, real numbers, in the question we did in exercise 1.2. So students, you have to revise the whole work we have studied today and note down in your notebook. In the next video, we will discuss more points about number systems. Till then, goodbye and take care of yourself.